All right, guys. So we're going to be going over lesson 9 from Stat 200. It's honestly nothing really all that new. It's again, it's really taking what we learned before and just applying it to a little bit of stuff that's new. It's really just dealing with paired proportions, paired means. It's honestly pretty chill. Don't have to worry too much. So I'm just going to go over a quick review of matched pairs. So basically, they're just cases that are matched in some way. An example of this is, if you're taking like a midterm and a final, like it's kind of pair. If you're taking like a midterm is in some way going to be like matched with the final because you can kind of, see how the grades work. You can see stuff like that. It's just related in the terms of like an experiment. But if you're going for an independent group, they're just completely unrelated. It could be shoe size and hair color. It could be, it's just has nothing to do with each other. A lot of times, it'll stand out, but you just might get a few questions about what a match pair is, just because this entire lesson is basically just dealing with them. All right, so starting off, we're going to just go with proportions, difference in two proportions first. Then we're going to switch over to difference in means. Then we just have some questions. So first off, you just got so first off, you've just got to identify which distribution you can use. So it's pretty much exactly like the way that we learned in the last lesson, where if the sample size times the proportion is greater than 10, and the sample size times 1 minus the proportion is also or like greater than or equal to 10, then you can use the z distribution. The only difference is that it has to be that way for both groups that you're testing. So there's going to be like group 1 and group 2. Both of them just have to be, fit within these guidelines. So if it doesn't work, then you have to use a binomial distribution. I think, they kind of went into it a little bit more maybe in the lesson that you could use something called the Fish's exact method. That's really only in Minitab. I'm not going to be covering it. I don't think you guys really need to worry about it. If they, talk about it in class, then that's great. You can use it, but it only really applies for when you're using Minitab anyway. So I won't worry about it too much. All right. So when you're constructing a confidence interval, we're just going to go into the assumption that you can use a normal approximation method. And so if you guys remember from previously, the general form of this equation is the sample statistic plus or minus the multiplier times the standard error. It's the exact same equation here for finding the difference between two proportions. It's just written out to look a little bit differently. So you see here you have P1 minus P2. That's going to be your sample statistic. The difference between them will equal your sample statistic, plus or minus your multiplier, which is the z-score here. And then your standard error is a hideous, hideous equation that is just going to end up being complete plug and chug. It's just the proportion of the first one times 1 minus the proportion of the first one divided by the sample size of the first one, plus the proportion of the second one times 1 minus the proportion of the second one divided by the sample size of the second one. It's really ugly to look at. It's, I really wish it would have been something a little bit easier to just remember, something that kind of like rolls off your tongue, but this is what we got. This is what we got. So long as you guys just remember, what goes into what, it's a really easy equation. And honestly, sometimes they just give you the standard error in the problem. So it's just really ugly back there. All right. So basically, we have to use the same 5-step procedure for conducting a hypothesis test as we've gone over, however many times. First, you have to check the assumptions that you have, that you can use this method. Then you should write out your hypotheses, what the null hypothesis is, what the alternative hypothesis. Then you're going to calculate the test statistic. Using the test statistic, you're going to determine the p-value. With the p-value, you're going to determine whether there's enough evidence or not to reject the null. And then you're just going to state that conclusion into a real world like way. So for the first part, basically checking the assumptions, writing hypotheses. These are your assumptions that, you know, if the sample size times p is greater than or equal to 10, stuff that we just covered a little bit before, normal approximation. And so these are the different ways the hypotheses could be kind of presented to you. So if the proportion, if it just says, are the proportions different, then the null is going to say they're not. The alternative is going to say that they're just different, and it's going to be two-tailed. If it says that group 1 is greater, again, null is going to say that there's no difference. The alternative is going to say that there is a difference, that P1 is greater. You can see it two different ways, really. You can see P1 minus P2 is greater than 0, or you can see P1 is greater than P2. I have it written out a different way later when it comes to means, but they're basically just interchangeable. And then that's a right-tailed test. And then if the proportion is of group 1 is less than group 2, same thing with the null. And P1 minus P2 is got to be less than 0, and it's a left-tailed test. So when calculating the test statistic, you use this equation right here. It's the p hat 1 minus p hat 2 over the standard error. Here's like the written out standard error. Lovely. And just for the p hat that you're putting in there is called the pooled estimate of p. So I don't really think you're gonna have to do it, but I'm just running out just in case. It's p hat of 1 times the sample size of 1 plus p hat 2 times the sample size of 2 divided by the sample size of 1 plus the sample size of 2. That's what you plug in here and here, since they're not really given to you whether you're supposed to use P1 or P2. That's basically what you're supposed to plug in. And technically in the equation, you could see it written out up top here of like p hat 1 minus p hat 2 minus 0. But that's the null, and the null is always going to say that they equal 0. But if it ever says the null is something a little bit different than 0 or whatever, then it would be put in there, but it's 0. So you're probably going to see the equation like this, but if you ever see like a minus 0 or something, I just don't want to throw you guys off. And then to finish it off, it's the same as usual. You use the test statistic, find the p-value, you make your decision, and then you state the real conclusion of that decision. I can tell like this is getting old. I think this is probably like being slammed in your face one too many times. So, all right. So with that, we're already on to the difference in the two means. So you might have seen it written out nicely in kind of like a little if-then kind of box plot thing. However, I just kind of wrote it out so that, because this is kind of like what helps me, is just like writing it all out. So basically, if you want to use a z-distribution, you can only use it if the populations are both normally distributed and the population standard deviations are known. If you want as a t-distribution, then you have two ways that you can use it. You can use it the populations are both normally distributed, but the population standard deviations are not known, or if the populations are not both normally distributed, but they do have a sample size of at least 30. And then if you want to use a bootstrap or a randomization distribution, yeah, the only way you can do that is if the populations are not normally distributed and they don't have a sample size of at least 30. So moving on, we have the difference in two means. So it's, why did I just say that? Sorry guys, I'm tired. So basically in the general form of conducting a confidence interval for the t-distribution, it's going to be the sample statistic plus or minus the multiplier times the standard error, which is, you know, same way we've seen it way before, same way we saw it in just the last few slides. And so it's just kind of like changed a little bit. So it's x bar 1 minus x bar 2 plus or minus the t multiplier, t star, times the square root of the standard deviation squared over sample size. The standard deviation of 1 squared over the sample size plus the standard deviations of 2 squared over the sample size of 2. Yeah. And then when you're calculating degrees of freedom, you're always going to use the sample size that's smaller. So you're always going to use the smaller n. That's just what you use for using the t star. So again, you have the 5-step test, assumptions, test statistic, p-value, decision, conclusion. So here's the table for writing out the hypotheses. So basically, are the means different? I kind of wrote out, as I said, a little bit differently. Instead of having mu1 plus mu2 equals 0, it's just mu1 does not equal mu2, which ends up resulting in a two-tailed test. If the mean of 1 is greater than the mean of 2, mu1 is greater than mu2, right-tailed. Is the mean of group 1 less than the mean of group 2, mu1 is less than mu2, left-tailed. Just, all stuff to keep in the back of your pocket for, when you actually get a question about asking how to write out the alternative hypothesis. It'll happen. I'm guaranteeing you it's going to happen. It's not fun, but as long as you just remember what it's asking for, you'll be fine. So then calculating the test statistic, again, you might see a -0 up on the numerator because, it's assuming that null is 0. It's just an annoying little addition, but, just again. So it's t equals x bar 1 minus x bar 2 over, again, the standard deviation of 1 squared over the sample size of 1 plus the standard deviation of 2 squared divided by the sample size of 2. They really need to make equations that are just easier to say because it just gets caught up and it's all mumble jumble. I'm sorry if you guys can barely understand me with this, but it's basically the same equation that just saw over here. So when it comes to finishing it out, you guys already know it's find the p-value, make a decision, and then state that in a real conclusion. It doesn't change, no matter how you look at it, those 3 steps are always going to be the same. And so, just remember, if you're ever doing this, degrees of freedom, always have to use the smallest sample size. If you use the larger one, then it's going to skew off your t-value a little bit, and it's not going to be fun. You're just not going to get the right answer. So with that, we're already into the first review question. So I kind of got away with a little bit of the multiple choice for this one just because there's not a lot of multiple choice questions. It's really just kind of find the word or find the interval or something like that. So in this one, it's basically a survey was sent out to a sample of students asking about their attitudes towards math during the first week of class and again the last week of class. So in this case, are the data gathered independent or paired? So I'll give you guys a little bit of time to work on this. Yep, you guys got it. These are paired samples since you're asking about the first week of class and again the last week of class, so they are related. All right, so V2 wrote out this nice long thing. So basically it's saying that the null is that the proportions are the same. The alternative hypothesis is that they're not the same. So in group 1, right here, they had 9 successes and 7 failures. In group 2, there were 11 successes and 13 failures. So have the necessary assumptions been met to use the Z distribution to approximate the sampling distribution in this case? Give you guys a little bit of time to work on this one. Yeah, you guys. I don't know why the values just changed there. That's weird. Okay. But yeah, no, you guys are right. No, you can't use it because both of them don't add up to the total of n. The n times p doesn't. The n times p, if it's greater than or equal to 10, and also, yeah, you're welcome for no trick questions. I got a lot of hate for that last one, so I'm gonna try and minimize it since you guys don't seem to like it when I try and actually test you. All right. So review three. So one proportion, two proportions, standard error of this, and it's asking for a 95% confidence interval. So yeah, I'll leave you guys to it. All right, so I'm just gonna go over this. You guys seem to be a little thrown off that I don't include a sample size, but it's not always necessary since they already gave you the standard error. So in this case, you don't really need a sample size. You just take the difference in the proportions. So 0.57 minus 0.43 plus or minus the 95% confidence interval, which the multiplier for that is 1.96. And then you just multiply that by the standard error right here, which is 0.0561. I just came up with all these numbers, like randomly. It's, you know, so you got a 0.12 plus or minus 0. I'm not even going to try. And then you basically just get a confidence interval of this. Yeah. So a lot of you, StatKey is an amazing resource as its Minitab. However, for the actual exams, you won't really get to use them. So I'm just trying to focus more on trying to calculate this stuff by hand, just because for the most part, that's what you're really going to be tested on. You're going to get quizzes and homeworks and everything about Minitab and StatKey, but I'm just trying to get you guys prepped for how you might actually be tested for these questions on exam. So with that, we go into review 4. Pretty simple, pretty straightforward. We're almost done, guys. We just got this and one more question, so I'll leave you guys to it. Yeah, good. I think you guys got it. It's pretty straightforward. Null is that they're equal. Alternative is that they just aren't equal. Pretty straightforward. Shift enter. Huh. The more you know. All right. So then review 5. This is just a Minitab output. This is something you might see on your exam. It's a way to test that you understand Minitab without actually like needing to look at Minitab. So basically, they give you all of the information you could possibly need just right here on this little snippet. So the questions are down here. So the question is, in this sample, which sex had the higher knowledge scores? And then, is there evidence that females and males have different scores in the population? So I'll give you guys a minute to look through this. I'm gonna go over it. So I don't have this snippet on the next slide. I just have it here, trying to save space so I can kind of like explain on this, but I'm just gonna go over it right here. So as you can see, when you look at the means, since it's asking for the difference, it's just the mean of one minus the mean of the other. So in this case, 10.96 minus 10.60. So men have the higher knowledge scores in this experiment. I'm not going to mention all the flaws that are probably in it, but regardless, in this very small experiment, they have a little bit of a higher knowledge score apparently. But when you look at the confidence interval, you see here that there is a negative number to a positive number, which means that the confidence interval includes 0. So the range has a 0, which immediately just tells you that there is not sufficient evidence to conclude that, you know, this is correct. So that's the answer for it. Whoopee. All right. So that's all for this review. I'm going to be in the exact same one again this Sunday at 9. I hope you all have a good night. Also, if I don't see you, happy Halloween. If y'all have any amazing Halloween costumes, I'd love to hear it. I'm planning on dressing up as Bob Ross, and my girlfriend's going to go as a painting. So, you know, I think that's going to be the best couple's costume. But yeah, have a good night, guys, and see you at the next one.